let's start with DVC. So what we're going to talk about, mostly we'll focus in on versioning. Okay, what is versioning in machine learning project? If you look on machine learning project workflow, from experimenting and machine learning development to prediction serving and continuous monitoring, we may find that versioning is everywhere. When we prepare data for machine learning experiments, sometimes we need to version data and understand what kind of data we used for model training, right? So when we go to continuous training and model deployment, we come to some configuration for CI/CD pipelines and models as well. So we need to take the specific version of the model that we want to deploy. And if we deploy a few models, we should understand which versions are in production and which models generate some specific predictions, and then we can track that model performance in different extent and different requirements, but the whole life cycle of machine learning projects requires some kind of versioning, including data, code, models, etc. How do you do the model version? So do you do it manually, or you use some kind of tools like DVC or maybe some others? So what kind of tools we have for versioning? I found this nice table from DAX Hub. There is some comparison for different tools, and DVC is here, of course. Today we'll focus on DVC because DVC is like a kind of universal tool that you can apply for different kinds of data, and it will work like from the box in most of the cases. Let's start it with DVC. And so what is DVC? So DVC is not just a data version control. This is like new title on the DVC website. So DVC provides like two kinds of functionality. First one is versioning, and the second one is a pipelines automation. With machine learning pipelines automation, DVC actually connects this versioning part and extends it to the metrics tracking and experiments versioning stuff. And it works on top of Git and provide this link between the versions of different artifacts in machine learning projects and your code. All versioning stuff actually is done by Git and stored in your Git repository. Okay, there is a online course about DVC that I worked on with DVC team. It's free. It's pretty good, I would say. And if you want to start, this is like good place to start with DVC because there are a lot of examples, explanations, etc., etc. So to start with DVC, you should install it, of course, and initialize the repository. So with the command DVC init, so DVC creates some metadata inside the repository, and you should just commit these changes to the Git history. I created the example here for you, but I already installed DVC from the requirements txt in some virtual environment. When you initialize DVC, DVC creates this .dvc folder in the root of your repository and add some files like config, git ignore file, and some others. So this is after that, so you may continue to work with DVC. Okay, and after that, we actually may start with version. If you want to track some file with DVC, you should just run this simple command DVC add. Let me just create a copy of this file. I just need another file for the next examples. Let's run command DVC add data iris2. CC. So DVC adds this file to the version control. What does it mean? It creates the additional file with .dvc extension, and inside this file, DVC adds some metadata about the file. So some MD5 hash, some other information, etc., etc. If we'll change this file somehow, delete something, etc. So DVC will understand this. And if we run DVC status, it should tell us that there is some modification in iris2.csv. So sorry for the previous one, because I deleted them. DVC actually doesn't show what exactly changes happened. It just highlighted that this file has changed, but in most of the cases it's fine actually, right? And after we added this file to DVC control, we can check status for the Git, and we see that there is we need to add this .dvc file with metadata to the Git history. So let's do it like this. Okay, actually, that's it. What we can do next? Next, we can do the same with any directory that we have in our workspace. So we can, using the same command, we can add a directory to the version control. You can share this data models or any other files with your colleagues. And to do this, actually, we can use remote storage. So remote storage is a place where DVC can just put this version of the file, keep it there, and when you need it, you can just download it from there. Okay, so let's create this remote storage. And remote storage actually can be not only in the cloud. You can create the remote storage on your local machine, but the idea that this remote storage is outside of your project workspace directory. So let's do this. It's created. Then we should add this configuration to DVC remote. So let's tell DVC that DVC remote add. So unfortunately, I already have these commands in my terminal, so I can just run them. If we'll go to the DVC config, we may see that here is a configuration for this remote storage added. You may have multiple different remote storages here, and when you work with remote storage, you can just specify which remote storage you want to use to push data to or download it from. We see that this config .dvc/config file was updated, so now we need to add it to the Git history. And so what we can do now? Now we can just run command DVC push, and this file will be pushed to that remote storage. So how we can check it? Actually, we can navigate to this file and find this MD5 hash. This is actually this hash is used by DVC to understand where this file is stored in the remote storage. And we also can list of files in our tmp.dvc storage. And here, right now, there are two folders, 4D and CF. So 4D actually is the two first symbols that we can see here in this MD5 hash. If we list files in this 4D directory, we can find this name of the file. And actually, this is the second part of this MD5 hash stored in our .dvc metadata. So this is how DVC stored files. It uses two first symbols as a name of folders, and the rest of the MD5 hash as a file name. Okay, what we can do next? We push the data file to the remote storage. Now we can actually remove this file from our workspace and restore this file using DVC pull command. Actually, the file is restored, so we can find it here. Okay, we have a question. Okay, let's continue. So this is how DVC remote storage works. Okay, it just keep your data somewhere and can bring this data to your workspace when you need it. And this mechanism can be used to create a data registry. So data registry is the concept that you can use your Git repository to version metadata about your data sets stored in remote storages. Because DVC has the dataset registry as an example in their GitHub. And there are also some commands that show how it works. So we can run some of these commands. So this DVC get command will actually just download the data from iterative data registry and add it to my workspace. Differences between this DVC get and DVC import, that DVC get is just download the data set. DVC import add this data and automatically and saves also the metadata about this data set. And after, if this data set is changed on the data registry side, so DVC will detect it and will be able to update this data and pull the new updates to your workspace. DVC import command will bring this file into our data repository. It should be faster. Yeah, it's here. And here is the data with a lot of images of ants and who else there. And this .dvc metadata file. So when we want to version data with DVC, DVC just calculates some MD5 hash for the data, then move the data to some cache and create these metadata files that you can version with your Git. And actually, this is how DVC understand what versions of different files we have. Now, in this branch, in the main branch, we have this version of iris.csv file. So now we can just, for example, check out the new branch. Here we can update the file. So let's just duplicate the data here. Git doesn't see any updates, but DVC should see these updates, right? So we should be able to commit this file. Okay, it's done. So now we should add this the new metadata for this file to the Git history. Okay, and run DVC push command. DVC push. So if we'll check the number of lines, so it's almost 300 lines here in this demo branch. Now we can check out to the main branch again. Okay, and automatically DVC didn't change this file, but DVC should understand that the file has changed. Yeah, has changed. And let's just do DVC checkout. Run DVC checkout command. Okay, it's expected errors. Let's do DVC checkout for this data iris2.csv. Oops. Yeah, now it should work. Now we go to our file and see that we have original file with 150 lines. So this is how it works. The next step is automating pipelines with DVC. So how it works? Under the hood, it uses the same mechanism as for data versioning, but DVC helps like give you some configuration template to automate the pipeline for your machine learning experiments, and can automatically version the inputs and outputs for this pipeline. To build this pipeline, there are some dvc.yaml file. For our example, we'll have a simple pipeline with 4 stages, like load data. Even we don't have loading data, we'll just extracting feature, splitting data set for train and test, and then train and evaluate stages. So we'll have 4 stages. And configuration inside this dvc.yaml file. So it looks like this, quite simple. Inside we have a list of stages, and for each stage we should specify the command we need to run for this stage, then specify a list of dependencies, parameters if we have some in our params.yaml file, and some outputs. I prepared some template for our use case. For our tutorial, it's quite simple, and inside there is only one stage, is a featureize stage. This stage actually runs this src/featureize.py command. So we can look inside. There are actually, it just rename some columns. This file read our data iris CSV file, original one, and save that features into the features underscore iris.csv file. And we specify these files in our configuration. So as a dependency, we specify the data set they used for this stage. Then we also specify the code for this featureize.py module itself as a dependency, and DVC will automatically track the changes inside this file as well. And then we specify outputs. So for output, here's our features. DVC exp run command. This command runs this pipeline for 1 stage. That's it. It's ready. We can see our features in the data directory. After running the experiment, we need to do this check the git status, and git status shows that this file is added. So we need just add this file to git history, like new, not experiment, but new run, let's say, something like that. So to make it like end-to-end, we just need to add additional stages for our experiment. I have prepared some notes for this, so let me just copy this configuration and add it here. Let's save and rerun our experiment. So we run DVC exp run command. As outputs for each stage, like a split data set, split it to 2 subsets that for train and test. The train uses, actually should use only the train data set like this, and generates model file, and evaluate stage takes this model file, run evaluation and save metrics into data eval txt file. So this one, and there are some metrics. So for that, we just add everything to the git, and like a new, because we just want to save this state of that and the results of new experiment. Okay, so we added this metadata to the git history. Now, if we want to save the outputs, all models and all other outputs that we specify in outs and depths, we need just to do DVC push command. And DVC push command will move all our 5 files generated by the pipeline to our remote storage. So we use this DVC exp run command to run the whole pipeline from end to end. we can specify the name of one stage and rerun this stage only. We can change some parameter in our params.yaml file. We don't have it, but if we have the params.yaml file and use these parameters as dependency for the pipeline, so DVC will track the changes in those parameters, and we can change those parameters like from using this big S argument. So we can use DVC then to run a lot of experiments. After the experiment complete, we may commit it to the Git history and save the versions of artifacts with DVC to our remote storage. And by this, we just can use that Git workflow approaches to machine learning experimenting. So create new branch for the new experiment, run new experiments there, commit them, then maybe merge them into the master or main branch. I guess that's it from my side, actually. So if you like, please use it, try it by yourself. If any questions you'll have, please let us know in any channel we shared with you, or just ask a question on our next meetups.